This is the video for 2.1 atomic structure. To start, we just simply need to know what an atom is made of. Okay, so it's made up of electrons, protons, and neutrons. There's a lot more, but this is all we really worry about in this class. Okay, so an electron, the symbol for it is just E negative. The reason it's the symbol E negative is because it has a negative charge. Proton, P, so it's just going to be P plus, and the reason it's P plus is because it is positive. So P, positive. Protons, positive. Neutrons is just N0. And why is it N0? Because neutrons are neutral. Okay? Mass, the main thing you need to know about this is that your protons are 1 AMU and your neutrons are 1 AMU. They are exactly the same. The electron is super tiny. So they're roughly 1 over 2,000 AMU. So when it comes to mass of an atom, they don't even look at the electron because it's so small compared to the other two. Okay? Now there's a long history of different models of the atom. The only ones that you're really going to be worried about is today's model and another one you'll see in another video. So today's model is called the electron cloud model. The whole reason it's called that is because we think electrons exist in these clouds. Now, the cloud isn't actually a cloud. It's just a space where we think the electrons exist. The atom is mostly empty space. When you zoom in on it, because it's extremely small, there's hardly anything even in that small space. The things that are in it, the nucleus. The nucleus is in the center. It's in the center of the atom. Inside that center, you have your protons and neutrons in there. So right here, this is showing you a picture. In the middle is your nucleus. Your protons and neutrons are in there. This contains all of the mass, or most of the mass, of the atom itself. The electron cloud is everything else. All of this space is the electron cloud. This contains most of the volume, and this is where the electrons can be found. So inside the middle, hold on. Inside the middle, you have your protons and neutrons, and then the electrons are on the outside. Okay? Now what we're going to do most of this video is you have to be able to tell me how many protons, neutrons, and electrons are in an atom. So that's what we're going to talk about pretty much from this point on. There are two ways to write a symbol. This is one. You have a number here and a number there, and then the symbol itself. So mass number over atomic number and the symbol of the element. So for example, 12, 6, C. So 12 is the mass number, 6 is the atomic number, C is indicating what element it is. In this example, this is carbon. Okay. Here, this is another way to write what element it is. So you're going to write, we'll do the same example, carbon, the element name, dash, its mass number. So carbon dash 12. Okay, it's going to be extremely important to know what number is what. Okay. Now we're going to be using the periodic table a lot. You see them in the classroom, you're going to have your own copy and so forth. So using the periodic table, you have this top number is the atomic number. So it gets a little bit confusing there because in the symbol it's at the bottom. So you need to remember symbol at the bottom is the atomic number, but when you go to look at the periodic table it's the top number. That number determines what element it is. Okay? The atomic number determines the element that it is. The symbol is whatever letter's there, then you'll have the element name, and then this number at the bottom is called the atomic mass. These equations are going to be what's going to get you through the topic. Okay, you have got to be able to count protons, neutrons, and electrons. And to do that, you have to know this information on this slide, every single piece of it. Okay, the mass number equals protons and neutrons. This should make sense because if you go back a few slides, the mass of the atom is determined by the protons and neutrons because the electrons mean nothing to us when it comes to mass. So mass is protons plus neutrons. You can rewrite this as just M equals protons plus neutrons. Okay, atomic number is equal to protons. So atomic number equals protons. A equals P. Now, in a neutral atom, only a neutral atom, it also equals electrons. in a neutral atom only. Okay, we're going to talk about what the heck that means later. All right. Now, to get neutrons, to get the number of neutrons, you're going to do mass minus atomic. So you can just do M minus A equals N. M minus A equals N. Okay? Man. M minus A equals N. Now, key thing here, and I talked about this on the previous slide, the number of protons determines the kind of atom. Okay? That is the atomic number. Remember, number of protons and atomic number are the same thing. So protons determines what element it is. So if I tell you the atomic number is 3, you're going to go look on your lovely periodic table, find the atomic number, because remember that top number is the atomic number, and then it tells you that it's lithium. So if I say the atomic number is 26, you go and find that top number, it is iron. Okay? So the number of protons / atomic number tells you what atom it is. Now this is just a cute little thing to help you remember. Ape man, the letters stand for atomic number equals protons equals electrons. Ape, atomic number, protons, electrons. Man, we just talked about this in the previous slide. Mass number minus atomic number equals neutrons. Okay, so ape man, that's how you find all your different particles in an atom. Let's do a couple examples here real quick. So one way you've got to be able to do it is simply a word problem. Now I'm going to redraw this because it looks funky here. This is how this should look. So it's simply asking for protons, electrons, and neutrons, and that's all I'm giving you. So the first thing you've got to remember is that this top number is the mass number. The bottom number is the atomic number. Okay? So with that, you should be able to tell me the rest of this. Protons, let's look at these. Protons, how do you figure that out? Protons is the atomic number. So if protons equals the atomic number, then you know it is 20. Electrons, all we're dealing with right now are neutral atoms, so it is also going to be 20 because ape man, okay? Atomic number is protons and electrons. Neutrons, this is going to be the hard one. A lot of times students will put 42 because that's the only number left, right? That is wrong. To find neutrons, you do mass minus atomic. You have to subtract the two, so you need to think of it like that, okay? You subtract the two to get neutrons. So you're going to do 42 minus 20, which gives you 22, and that's all you got to do. That's it. Voila. Now, the other way you got to do it is simply by a picture. Here it tells you what all the little things are, gives you a picture. You should be able to tell me the rest. So protons, just the number of them. So you're just going to count the black dots. So 1, 2, 3, 4, 5, 5. Neutrons, it tells you it's the clear big circles here. So 1, 2, 3, 4, 5, 6. Electrons are the gray ones, and they're on the outside where they should be. So 1, 2, 3, 4, 5. Okay, just from a picture. Now, in the previous example, I gave you the mass number and atomic number, and you had to find all that. Now I'm giving you this stuff, and you got to figure out the atomic number and mass number. We're going kind of backwards here. So how the heck do we find atomic number? Remember, atomic number is the number of protons. They are always the exact same thing because it determines the atom. So protons equals 5, so atomic number equals 5. Mass number, what's determining the mass? You've got to remember that this middle part is the mass of the atom. So all you're going to do is protons plus neutrons. So protons plus neutrons, 5 plus 6 equals 11. Now, symbol. Symbol just means you're going to put 11 over 5 because it's always mass number over atomic number. And now we have to figure out what letter it is. How do we find that? Remember, this bottom number is the atomic number. That determines what element it is. So you find the atomic number of 5 and you figure out the element, and it is boron. So you're going to put a B, and there you go. The end. A couple more definitions we need to talk about here. Isotope, this is going to be a key word here. That's a key vocabulary word. Is the same element with different number of neutrons. Protons are the same, electrons are the same. The only thing different when it comes to counting is going to be neutrons. Now, because the neutrons change, the mass also changes, okay? So what you need to know, isotopes, same element, different number of neutrons, therefore the mass changes. That is literally the only thing changing about the atom. All the other properties, chemical properties and all that, are exactly the same. Neutrons just determine the mass of it, okay? Therefore, they have different mass numbers too, like I just said up there. Okay, example, carbon-14 and carbon-12. They are both carbon. They both have the atomic number of 6. Okay, if you look at the periodic table, they both have atomic number 6. The only thing different is that lovely neutron. Okay, so if we look at neutrons, to get neutrons, you're going to do mass minus atomic. So 14 minus 6 gives you 8. Here, 12 minus 6 gives you 6. So the mass number and the neutrons are different. One more vocabulary word here, atomic mass, not mass number, atomic mass. Now, here's the thing. This mass number is specific to this isotope. Okay? This carbon has a mass of 12, this one has 14. It is specific to that element that it's there. Now, atomic mass is the weighted average of all isotopes of the element. It's an average, so it's an average of these two, not one specific atom. Okay, it depends on the amount of each isotope. So if I have more of carbon-12, the average mass, the average atomic mass is going to be closer to 12. Okay, that is what's on the periodic table.